Yeah, look at the question 7. The question 7, a capacitor and an inductor are connected in two different AC circuits with a bulb glowing in each circuit. The bulb glows more brightly when. If you are looking at this question, you will find you have to read the NCRT books very properly. This question is a example question from the alternating currents. Okay, always I used to suggest my students, please read the example questions immediately after the concept explanation, because they're exactly conceptual oriented answers as given. Therefore almost they'll get the knowledge of 2 3 questions indirectly from the exam problems. So in future we have to follow this also, other students. This is my request, whoever wanted to grow in physics. So what is the option? What are the options? The number of turns in the inductor increased. Usually the number of turns will increase, what will happen? Inductance will increase, nothing but I can say, or magnetic field or EMF inducing across the inductor will increase. EMF induces, but across the inductor it develops, but that will not helps to glow the bulb. Okay, all the EMF accumulates here only. Next, the separation between the plates of the capacitor is increased. Of course, separation between the capacitors will be increases. C is inversely proportional to D. Then what happens that automatically capacitance will be decreases. Since capacitance is decreasing, in the sense the providing or the flow of charge will become difficult between the plates. And next, if you see an iron rod introduced into that inductor, due to this also EMF generation will increase across the inductor, that decreases the intensity of the bulb. Okay, and that will not help to glow the bulb much. Option D, if you see, a dielectric is introduced in the gap between the plates of the capacitor. When you introduce a dielectric, the potential difference between the plates will increase. Therefore, charge transaction between the plates will be increases much. So, due to that, flow of current takes place much in the circuit. So that's why C equal to K. K gives the dielectric constant. This is directly proportional to the capacitance of the capacitor. Indirectly, this helps to move more charge across the circuit. So current flow develops. So that helps to glow the bulb more and more. Okay. This is one way is my analysis. Confirm. The next question you can see, a pure inductor of 318 millihenry and a pure resistor of 75 ohms are connected in series to an AC source of 50 Hz. Okay, we know that by seeing that AC source and inductor and resistor together, we are seeing we got a splash start, that is LCR circuit, right? So the voltage across 75 ohms resistor is found to be 150 volts. Okay, and the source voltage is how much they are asking. Across 75 ohms is 150 volts, but what is the source of voltage is question. Now simply what we have to find, we need to find the impedance. From the impedance we have to find the source of voltage, but for that we need to know current. How can we find the current? We will find the current. You can have a glance here. First, we know inductance and resistance as well as linear frequency as given. Linear frequency we can write in terms of angular frequency also, that we know very well. What is that? 50 Hz. You can write in terms of omega equal to 2 pi f, right? So 2 pi f, it will become 100 pi. Okay. Now XL equal to omega into L. What is the XL stands for? Inductive reactance. I can say the resistance in the inductor circuit, omega into L. So omega and L value is substituted. So this gives XL value. Okay. For avoiding time, just don't calculate here, just directly we will substitute wherever you require. Before I need to find I equal to V by impedance r square plus xl minus xc whole square. Since xc is neglected here, means it is not mentioned xc equal to I did not consider here. So from this formula I cannot find directly source of voltage. For that I have a resistance as well as voltage. From Ohm's law I have I can find easily. V has given 150 and 75. Therefore, from there I equal to 2 amperes I got. So what I did, this current I have used, of course current is constant, though it is in series and parallel, we know that. Parallel of it gets divided, in series it is constant. That's why in LCR circuit I am taking 2 amperes in the total current way. Total current in the circuit is 2 amperes. So the 2 amperes I am multiplying with the impedance. Impedance stands for resistance in the LCR circuit. So V equal to I into inductance, how much I got, and the resistance 75, inductance 100 whole square. So the total, if I'll multiply I into this, I got the answer is this much. Okay, the answer gives us 100 whole square and 150 is 250 volts I got. Okay, so there you are finding 250. This is actually 250 volts. We got the answer. So this is direct substitution only, but we need to understand what is what to connect here. Of course, most of the people will feel, of course, if you could practice the model paper books and the basic NCRT problems, NCRT same model problems we have in the exercise, not a that level, very simple level problem is this. Once if you have this method remembrance, you can do. Next, question number 9th. The electric potential at a point on the axis of a short electric dipole at a distance x from the midpoint of a dipole is proportional to. Usually electric potential due to electric dipole along the axial point, whatever the equation is there, that if you are considering as a short distance, obviously that is proportional. V is the k p by r square is, we know that we have an expression of this. So since we are considering dipole is very shorter, then so that I can write V is directly proportional to R square, indirectly proportional to R square, means we say inversely proportional. So the answer we can go for the D. I hope direct. Just you can remember the expression. If it is axial point at longer distance or smaller distance, the dipole behaves in same manner. With respect to distance, it changes. Next, this is very clear answer from basic Coulomb's law. Let F1 be the magnitude of the force between two small spheres, charged to a constant potential in free space, and F2 be the magnitude of force between them in a medium of dielectric constant K. Remember, F1 is a magnitude of a medium in vacuum, means the dielectric constant is 1, let us say. F2 we can take up as between the medium they have provided is K. So F1 by F2, when you are going with the Coulomb's law, F1 case you can find how much you will have. F1 I am taking directly rest of the all constant 1 by 4 pi epsilon naught. In that case K only I am preferring, 1 by K, rest of the charges I cancel. 1 by 1 for F1. For F2 1 by K I have taken, right? So that can be written as equal to K. Therefore F1 F2 equal to K is a answer for us for this question. Okay, therefore answer is B, right? You are seeing the dot mark B is the answer for that. If you want, I am highlighting more here also. Okay, this is 2. Now next, infinity resistance in a resistance box. Obviously resistance box, while you are using, maybe you might have used in meter bridge experiment and potentiometer experiment, most of the times you are taking out the resistance, you are checking with the checking null point for the different resistances and all. It means 100 ohms or 1000 ohms you are taking out, in the sense nothing but what you're doing, you're applying the resistance. Okay, if there is a gap in the middle, if you're creating, sometimes it will not respond only so infinite amount of resistance may act. So our answer is D, the gap only gives us infinite resistance. Okay, so next questions will continue in the next video.